In the second video I'm gonna show a bit more about debugging MINIX, at least using the bootloader on the emulator. I'm first gonna kill off my session. Alright. So where did we left off? We left off, we had an image here and we want to start debugging it. Let's have a short look at the object tree. If you look here, first we're gonna look at the tool there. This is where all the tools are present. The compiler, the BSD make and other things. This needs to be in your path if you want to do some more debugging. So normally you would put this in your bash profile or something. Only every time your version changes, Linux version changes, another directory will be created, and it can be a bit painful. So this is those are tool there, and then there's some other directories like servers, where the servers are, the kernel, the images, drivers. So there's a lot of code here, and well, that's it. If I go back to my source directory and I want to debug, you don't need that much actually. You just need to start your emulator. You just need to start your emulator. I added my run script to add a -s flag, so it waits for the debugger when starting. And I'm gonna run GDB. The only problem here is that we don't have a cross GDB enabled by default, so you need to get a cross GDB from somewhere else. I'm gonna use the Android one because you can download the NDK, and Code Sorcery is a bit of a pain to download, and well, just works. Right. Given this, you can actually just directly debug. You can connect to your debugger and start debugging. It will load. You might want to stop it at some point. Control C, and now you can. Well, you could do some debugging there, but this is not that useful because you need some more some more stuff there. Right. So I'm gonna detach the process. I'm gonna kill my window again. Right. Now I'm ready, and we're gonna debug a bit of the kernel. First I need to know where the kernel is loaded. Well, I actually know it, but I'm going to show you how this happens. The entry point is this address of the kernel. So U-boot will load the kernel and put it. Well, load the elf has. Well, it's created as a flat binary. We're going to load it into memory, and we're then going to start executing at that point. You see also that the load address here. This is the real address where the code should be loaded. Right. I'm going to launch GDB again. I'm going to add a breakpoint at that address. I'm going to launch my emulator. So it started. I connected. I added a breakpoint. I'm going to continue. Now it's just going to boot normally. The ROM code loads the bootloader. The bootloader does his stuff. and the breakpoint gets hit. At this point we're at the first assembly instruction that's being executed by the kernel. You can view that because you can do something like layout ASM, and here we'll see the first instruction is a branch to well, just a little bit further. So we can do a step instruction. We can continue. So now we're gonna load the stack pointer, and we continue like that. So I could go on like this for hours because there's a lot of code being executed. So you could go there quite well. Right, we're gonna detach again. Just get the code running. Now, if you want to debug the code viewing the source code, you need also to map that code to the kernel, and therefore you need to compile your kernel with debugging symbols. I'm gonna do two things now. I'm gonna do export of dbg. So that when I call the release script, it will create with debug, and I'm gonna export my C flags for later. You're gonna see. All right. Yeah. I'll do this window because I've set up the path here. And we make. We're gonna clean the kernel because we're gonna want to make sure it's gonna be compiled, and we're just gonna call the whole release tool release image. Let's see how long it takes. Right. So now mostly the kernel will be recompiled, and it's going to be compiled with -G flag, so it will include the symbols, and a new image will be created. Right, so my minutes are a bit longer than normal minutes. It took a few minutes actually to compile. I'm going to start GDB again. I'm going to use my kernel file to read symbols. So it's reading symbols, it found symbols in there. I can do a break under, I think, pre-init. So that's the code that's executed before the MU is turned on. It found a breakpoint here. I'm going to start the emulator. And continue. Now it should break in pre-init, which is pretty early in kernel debugging. Kernel world. Alright, I think it's found it now. Yeah, so it's really at memset. Backtrace what I do. Well, it's in pre-init and in startup code, and now you can just really step through the code. And well, that's what I can show you for now. When it gets a bit harder when you start debugging multiple programs, because now at this point the MU is not turned on, and it's very easy to find the right program. But more on that later. What you can do is load the program, the special address, so the breakpoints still match. That's it. Greetings.